Welcome everyone to this session. We are dealing with quadrilaterals, part 2 of it. So we started firstly with triangles. So 2D shapes is divided into 2 triangles, and then today we're dealing with what? Quadrilaterals. So this topic, I'm gonna quadrilaterals. This topic I'll be mainly focusing on this part. So obviously we did a detailed video on triangles. We've got 4 kinds of triangles that we have to know. An isosceles triangle. Isosceles, if I write iso, it's fine. Scalene. What else? Equilateral, and then a right angle triangle. So you need to know the properties of all of this and be able to use the properties to make necessary calculations, especially when we're dealing with the isosceles triangle. We know that the base angles are the same and blah 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 blah. So today we're dealing with quadrilaterals. Quadrilaterals, what are quadrilaterals? Quadrilaterals are figures that have 4-sided figures, and they have four angles inside. So they have 4 sides and 4 angles. Are we all clear? So we're gonna do types of triangles, but we're gonna mention the first property. We know that in a triangle, all interior angles add up to how much? 180. So in this one, all interior angles of a quadrilateral, interior angles of a quadrilateral add up to how much? 360. So angles inside the quadrilateral add up to how much? 360. So for a triangle it's 180, for a quadrilateral it's 360. So how many shapes of quadrilaterals do we have? We have 6 shapes. So I'm going to mention them here one by one. So quadrilaterals, we've got number 1, a kite. Number 2, we've got a trapezium. And then we've got the main one, a parallelogram. So a parallelogram is a shape on its own, but it's also a mother shape of the following. So underneath the parallelogram, we've got a rhombus. We've got a square. We've got a rectangle. So you're going to see when we do the properties. So a rectangle, a square, a rhombus is also a parallelogram. And a parallelogram is a shape also on its own. So 1, 2, 3, 4, 5, 6. Can you all see? So let's start with the first one. The most basic one that we can start with is what? Let's start with the parallelogram. So a parallelogram, I'm going to do parallelogram. I'm going to try to do a short picture. I'm going to try to draw it here. Yeah, something like this. Okay, let me just use it up to scale like that. Okay, so it's not drawn up to scale, but I'm sure you can see. So the parallelogram is a shape that is like that. So what we need to know is that opposite sides of a parallelogram are the same. So this side and this side is equal. This side and this side is equal. So let's just say A, B, C, D. So opposite angles, opposite sides are equal. So AB will be the same as CD, and then AC will be the same as BD. Another property that we need to know is that opposite angles are equal. Very important. So opposite angles are equal, meaning what? This angle here will be the same as that angle there, and then this angle there will be the same as that angle there. So these angles that are opposite, they are equal. Opposite, they are equal. We're fine with that one. Okay, let's continue. Another property that we need to know of a parallelogram is that opposite sides are parallel. Now this is very important. They are parallel. Once they tell us that something has parallel, so what do they mean by parallel? Meaning this side and this side is parallel, this side and that side is parallel. So I can make two arrows to show this AB is parallel to A to BD. Remember what we said by the word parallel, meaning they are the same distance apart from each other. But that is not the case, like the most important part in this case. The most important part in this case is that when they tell you that opposite sides are parallel, we can apply those rules of parallel lines to calculate an angle in a parallelogram. So the first rule that we know of parallel lines is that alternating angles are equal. We can apply that one. The other one is corresponding. Corresponding angles are equal. The last one is co-interior angles add up to 180. So you can apply these three rules of parallel lines. Remember, these are parallel lines. They form what we call fun. You still remember that, I hope. So corresponding, co-interior, and alternating. So we can apply these three rules when we are calculating an angle in a parallelogram. So I'm spending most of the time in this one because that's the special one. That's what we usually test on. And then the last property that we need to know is that diagonals bisect each other. So this is diagonal, and then this is another diagonal like that. They bisect each other, meaning they cut into two equal parts. Eh? So diagonals bisect each other. Right? So this is going to be very important when we're dealing with congruency and similarity, because of now when we've got a diagonal line like that, it divides the parallelogram into a triangle. But you're going to see that when we're dealing with congruency. So what we mean by that this side will be, if they bisect each other, this side, maybe here it's EB will be the same as EC, and this one will also be the same as that one. Let me just use that symbol there. Let me use that one there. So these are the how many properties? 1, 2, 3, 4 properties that you need to know about a parallelogram, including the main one, that all interior angles in a quadrilateral add up to 180. Okay, let's move right along. Okay, I hope you can see. Rhombus. We are on a rhombus now. Rhombus. What do you know about a rhombus? Rhombus is almost similar, just that all sides are the same. So if you draw it up to scale, not like me, this one is not it. But let's assume it is, for argument's sake. So if it's a rhombus, this side and this side and this side and this side should be the same. So all sides are equal. That's the first thing. And then still opposite angles are equal. So this one and that one will be the same. Opposite what? Angles are equal. We're still on a rhombus, right? And then opposite sides are parallel. So this will be parallel to that. That one will be parallel to that one. So opposite sides are parallel. So remember, when we say parallel, we can apply those three rules: co-interior, alternating and corresponding angles. So opposite sides are parallel. How do you see parallel lines? By the arrows. So once you see the arrows, we know that we can use. If the arrows are not there, we cannot use the rules of parallel lines. I hope you get it. We cannot assume that they are parallel if the arrows are not there. We need to see the arrows for us to know that the lines are parallel. Okay, then the last one is that diagonals bisect each other at 90 degrees. So this one is very special. So the diagonals bisect each other, and the angle here, it's 90, 90, 90. So they bisect each other at 90. So diagonals bisect each other at 90 degrees. Okay, there you go, right there. So that's a property of rhombus. Rhombus, rhombus, rhombus. Okay, let's move right along. A rectangle. Let me try to draw it there. Rectangle. Hey, what am I doing there? A rectangle. What do you know about the rectangle? So if you're in grade 8 or 9, you should know what is a rectangle. A rectangle is something like this. Yeah, I'm using a ruler now. I hope you can see. Okay. Okay, cool. So one thing we need to note about a rectangle is that all angles are equal, and that equal to how much? 90 degrees. So every rectangle has right angles. So all angles are equal, and they're equal to how much? To 90 degrees. Number 2, opposite sides are equal. Can you see why we said a rectangle is also a parallelogram? Because of the properties are the same. So this side and this side are the same. This side and this side are the same. Are you all clear? And then what do you know is that diagonals bisect each other also. Diagonals bisect each other. So if we have a diagonal line passing through there and there, the distance here and the distance there, let's make 3 strikes, should be the same, and the distance there and the distance there should be the same. Are we clear on that one? I don't know if I'm missing anything. There are also opposite sides are parallel again. Can you see that it carries the properties of a parallelogram, even though it's a rectangle? So that's why we say all this, they all fall under what? The umbrella of a parallelogram. So the last one that we still have to do here is a square, then we do a kite and a trapezium. So let's do a square. What is a square? Yeah, the drawing is the one that is taking a lot of time. So I'm just gonna make a rough sketch. Yeah, don't be like me. You need to use a ruler. So all angles add up to 360, and they're all equal. They're all equal to 90 degrees. All sides are the same of a square. We know that all sides of a square are the same. Diagonals are equal in length, and they bisect each other at 90 degrees. So this side and this side is the same. This side and this side is the same, and then they meet at a 90-degree angle. So I won't write those properties, but I hope you got them. Then let's move to a kite. A kite. How do we draw a kite? Something like that. We know that, especially if you used to fly kites when you were young. Something like that. Okay. So what we need to note is that adjacent sides are the same. Adjacent sides are equal. So this side and this side are the same. This side and this side will also be equal. And then what we need to know is that one pair what am I writing there? One pair of the opposite angle is equal. So this pair of opposite angles are the same. So if they tell you that this is 70 degrees, this will also be 70 degrees because of that. And then lastly, only one pair also of diagonals bisect each other. So one pair of the diagonals, I hope you can see what I'm writing. One pair of the diagonals bisect each other. Okay. So if we have something like this, can I use a different pen? Let's say we've got a line passing there and a line passing there. So this one will be the same. And this diagonals, they cross at the 90-degree angle. So where they meet, where this line, the horizontal, vertical line and the horizontal meet, they meet at 90 degree. So this part already, we know the angle in there because of it's a right angle. And the last one is a trapezium. Trapezium looks something like this. I'm gonna try to draw it here using a ruler. So it looks like something like that. So can you see, this side is not the same as that side is not the same as that side. There's only one property of a trapezium, is that one pair of the opposite side is equal. So only one pair of the opposite side is parallel. And that's when we have that word parallel there, we know that we can apply those three rules when we're looking for angles. I hope you get it. So this part, I was just listing out the properties of quadrilaterals. And if they ever ask you a property of a quadrilaterals and then you forget, you're just gonna have to say this one, that angles inside a quadrilateral, any quadrilateral will always sum up to 360. So let's say they ask you a property of a trapezium and you forget it, or the property of a kite, you forget it. You can just simply write this one, that angles inside a quadrilateral will always sum up to or add up to 360. So I'm going to do a question immediately after this video where we basically doing questions on this quadrilateral. So please watch out for the video where we're doing questions so that you can know how to apply these rules and principles that we learned. So thank you so much. Like the video, comment if you learned something, and I'm gonna see you shortly.